on their M3 front-end workstation, you can actually go into their graphics and override a room temperature. I think it's Johnson, whichever one, but some software packages will allow you to effectively override a room temperature. So now you've accomplished something. You've changed the room temperature.
I actually have the backdoor code somewhere.
Oh, really?
Yeah.
But one of the problems is if you've just overridden a point, you've just overridden a point. You haven't really affected the system and how it operates. You've just made something look better on the graphics. We prevent that from happening. You can click on the point all you want in one of our systems, and if we've set it up as a read-only point, it's just that. It's a read-only point. And we do that as a standard to try to keep people from making common mistakes.
Accidentally.
Yep.
Keeping their finger on it too long, making it 105.
Yeah, yep.
What happens when there really, well, I suppose it would be taken care of automatically. I was just saying there really is an issue, like somebody's opened a window that you're not expecting. Or, I don't know, I mean.
Yeah, how do you take in the human behavior?
So it's good questions, and the hardest part of our job is working with people. The biggest complaint we have is somebody will complain that they're hot or cold, and usually the things that they do on site are a large part of the problem. For example, the little electric plug-in heaters, portable heaters. It's inevitable that somebody's going to be warm in an area while somebody else in the area is cold. It's just, if you put two people in a room, one's going to be warm and one's cold. If they share a same zone, for example, where this VAV serves, if two people sat in that zone and one of them was hot and one of them was cold, in order to keep them satisfied, we might limit the range of adjustability at the thermostat so that they're not constantly up and down, causing problems back and forth for each other, which gets them into somewhat of a comfort zone because of the consistency. What'll happen is somebody will sneak in a little desk heater and they'll plug it in, and they're fairly quiet, but they add a lot of heat to the room. So the next thing you know, that heat is influencing the system, and the system is trying to go into the cooling mode. So they're actually making it worse for themselves, even though they feel it's good. So we can usually find that information by analyzing trends, and that's one of the biggest.
Does it keep the data?
Yes.
Data logger built in?
Oh yes.
Cool.
Can
Yeah.
you monitor power usage?
Yes, absolutely. We do that on a lot of projects. Yep.
So wouldn't that be, I'm just thinking of the evil guy side, a good way to keep people from bringing in heaters. As long as I can monitor his cubicle usage, it says it goes up, I know they're running a portable heater. Same thing with tying it, could you, like for open windows, to compensate your system to allow it, couldn't you tie them with the alarm system, so when the window's open?
Yeah, we can. We actually have quite a few sites. We actually control the windows. Especially like on real high-end residential projects. Anderson makes a pretty basic motorized window operator. I have them in my house, on a skylight, and they're very basic. It's just an actuator. So we send it a signal to open it, send it another signal to close it. So we'll actually do that quite often. But trend data is very important.
You could make someone totally insane.
Oh, you can automate your house completely if you really wanted to. I mean, you could actually have your coffee pot turned on and turn down.
I'm just thinking about being in a house and having the windows open and closed.
I was
Would
a
you
smart
clean
house.
up for me that way after I'm done? That's what I want.
Have breakfast made yet?
Well, if
We're-
breakfast made, that's easy to do.
You can almost do that.
Yeah.
What about, and this may be a kind of irrelevant question, but what about when systems fail? What about buildings where everything is automated? I mean, whether a system fails or whether you get a blackout or whatnot, is that just, a building isn't gonna work with no electricity?
Well, I mean, if the electricity goes out, we're doing a project right now out at the seacoast, and unfortunately, I'm not at liberty to discuss the actual project, but it's one of our most sophisticated control systems that we've ever designed, and it's a design-build project. We've been working on the project itself for probably upwards of, we're quickly approaching 3 years. we've been designing and installing a control system in a project, and we've probably got maybe 2 to 3 years left to go.
Wow.
And it's a work in progress. Well, that was the question that got asked. What do we do when the lights go out? So they decided the first step, they said, well, we're going to put in generators. And so they went and got a bunch of generators, and the project requires that everything be very, very quiet on site, so the generators are located quite a ways away. That was quite a project. And because of the distance that the generators are from the project, made some limitations as to the size that they could make on the generators and how they could, put this package together. So that what they ultimately ended up with was undersized generators. So if the lights go out, the idea is that we're going to know that from our control system, because the generator is going to flip over to run on, they're going to start up and re-energize the house. We're going to know that instantly, and just as fast as software and electricity can flow, instantly we're going to shed load, unnecessary load in the facility, so we don't overtax the generators. So items like certain lighting circuits, certain electrical apparatus that normally would be operating, we're going to be turning off. We've got a whole schedule of sequences that will meet instantly. So and then once those components are verified to be off, only then will we allow the second generator to kick in. So we're actually, the initial generator that powers just the most basic components, including our building automation system, comes on. We determine that, hey, that one kicked in, then we transfer over to the, you transfer the loads, and then start the second generator.
Have you used control systems to integrate hybrid renewable systems at all? Like wind energy with photovoltaic energy to the grid, or?
Not necessarily. We've got solar. We're working with solar projects with solar collectors. It's and with the newest, I'm really excited about the newer solar collectors, the vacuum tube solar collectors that for hot water, that make hot water. Those are, I mean, we've been seeing those on some of our projects, and I mean, it's phenomenal. I was on a project with one panel, one solar collector had 3 inches of snow on it on a cloudy day, and it was making, I think, like 70-degree or 75-degree water. And it just, I mean, you're working on ultraviolet light. What's that?
Do you remember what kind it was?
That was made by Viessmann.
It was a Viessmann.
Yeah.
There were a lot of nice evacuated tubes. Energy showed on Boston.
Oh, is that right? I didn't see, I didn't get down to that one, but,
This is a pretty good one.
so, but I may be able to show you that project today as well.
In that instance, was it to a radiant heat system, or was it for a hot water, like a preheater, or
That,
other heating system, or?
that ties into the, we can use that hot water, it's on a residential project. We use that hot water generated by the solar panels to heat the indoor pool, the outdoor pool, radiant snow melt outside in the driveways, and also, and we can share it. We can send it to different areas.
For me, I didn't think about the swimming pools, I was thinking
Yeah.
about hot water inside the,
But, and then that,
changed my mindset.
but one of the things that we're seeing now is in both commercial and residential projects is designers, the mechanical engineers, they're getting creative. So they're just grabbing all kinds of these technologies and putting them all on a project. So, while the solar may be great in, part of the year and some areas and some days,
That's what I was asking.
the next,
The hybrid system.
Exactly.
For electricity specifically is really,
Yep.
in these parts of New Hampshire makes the most sense, along with the solar thermal for water.
exactly. We are working on a design. I don't know, it doesn't look like the project may happen right now, but there's a project in place with one of the pellet manufacturers, where they're trying to, they've got another business being, next door that is going to make some of the, use some of the byproducts of the pellet manufacturing, and they're kind of feeding off each other in some ways. And one of the aspects of what they're doing that generated some interest on our building automation was dust. So we were thrown into a design of, well, we want to mitigate dust in an energy efficient way. So, well, we designed a system. We've yet to install it, but we've designed a system with opacity sensors to actually measure the quantity of dust in the air. And,
And what do you collect dust through, electrostatic
That's what I was,
collector?
exactly what I was.
no, this one's just a typical ventilation system, you know, dust.
Just use supply
Like a vacuum.
Yep, it's yeah, they've got a makeup air system and an exhaust.
No, because I was just thinking, you know, if they're making wood pellets, they're generating a lot of dust. If you can recover the dust, they
And
can
like
back
pellets.
it. Make pellets out of it.
Oh, they may be doing that too. I didn't get so much on that particular project. I wasn't invited into the manufacturing aspect of it. Sometimes we do, but most often we're not so much into the manufacturing side of it.
They spent a lot of time working for an R&D department for a company that made all kinds of machines.
Oh, is that right?
Yeah.
Yeah. I mean, there's,
The flat mail sorter they used to sort your mail in the post office, I
Mhm.
built the first one of those.
oh, wow,
The first completely automated munitions plant, built the first one of those.
wow, wow.
Indoor air quality you were talking about, the program that you talked about?
No, this is just room temperature. This
No,
is,
I mean for what you were just talking about
Oh.
with
With the pellet.
with the pellet place.
yeah, it was basically, yes, to maintain, I mean, they wanted to reduce, the design intent was to reduce the amount of dust in the air for dust explosion, for safety reasons, in the most energy efficient way. So the normal way for dust collection is to have basically a dust collecting system installed, and whenever the process is going, to turn it on and it runs full speed. So the mechanical engineer that kind of laid out the project, one of his challenges from the owner was to you know, I don't want to be bringing in X amount of CFM of outside air all the time, because at times our process is slow, so we don't make as much dust. So they wanted to basically modulate their dust collection efforts to save as most energy as they could. So the one way I looked at it, you know, and again, most of this starts from a common sense approach, and then a lot of research to back it up. But the approach that we took was, well, if there's not as much dust in the air, our dust collection efforts need to be a lot less. So you know, we designed a system based on that would actually measure the amount of dust in the air. And we worked with, I researched this out, and this actually took quite a bit of an effort, you know, and time to go through this, but we found a manufacturer that makes opacity sensors for smokestacks. And we took that technology and we, you know,
Modified it to-
Was that mostly for like emissions where?
exactly, yep. So
And it measured parts per million of sawdust?
it wasn't so much parts per million, it's concentration.
Okay.
Okay, that, and you know, the engineers and I forget the name of the company that we worked with mostly, the opacity sensor, company that builds the opacity sensor, they have their own lingo and jargon that really works. But one of our main requirements was to be able to measure concentration in the air, as well as doing it in having a device that was explosion proof. So the device itself that we put into the space had to meet certain criteria. So and they actually do all that. So we're challenged with something. So what we do, and then we do this in building automation often, is we look at the needs of the customer and then try to develop whatever technologies, pull together the technologies to make it happen.
You ever require UL certification on stuff that you're manufacturing? for
Yep.
Safety? You're
Yep.
saying so it doesn't explode, I'm thinking, boy, my laboratories would be on that one.
Yeah, New Hampshire is a little unique from the rest of the country. New Hampshire's state electrical inspectors, and this kind of, we're way off track here, but that's fine. For our going through the installation, I mean the construction, building automation cycle, our installation department, we have our own folks that do our own installations there. Most of them are, all of them are licensed electricians. We don't actually need to be licensed in New Hampshire to do low voltage control wiring. However, we found it as a company, we found it in our interest to put professionals in that area, because they're wiring and they're working with line voltage. So rather than have a gray area and get kind of caught with our hands in the cookie jar that they're not supposed to be in, we decided to, as a company, to just go with licensed electricians for our installation department. That is open. I mean, New Hampshire is unique. They allow us to just go and install anything we want without a license, but the state electrical inspector requires that any panels that have more than one device in them in New Hampshire be UL listed. So if we make a control panel, if it has, you know, a DDC controller and a few sensors in it, it's got to be UL listed. So we went through the process of becoming a UL listed panel shop, licensed, you know, or certified by UL to apply stickers to our control panels. And we're regulated by and monitored and controlled by UL. So when we do a control panel, it'll have a sticker on it and it'll meet all the UL requirements. Now, and that's UL 508, but what you were kind of talking about, if we were to build a system, you know, in an environment like that, then we would actually have a PE, have a licensed, you know, engineer, you know, certify that it's, stamp it, that it's, you know, going to meet whatever requirements that the owner is going to require. That's one thing we don't, and most building automation contractors don't have, is PEs on staff, you know, for that application. So, but we know where to find them. So back to what we were originally talking about. This is all great, though. I love it. We were talking about the trends and troubleshooting. One of the things you know, you look at is if a customer has a problem or a complaint, you know, you want to look at the data, the current data of what the situation is. So we'll jump online with a site and look at what the conditions are. And then that'll give you a snapshot in time of what's happening, but then we can actually go back in time and see what's been occurring over you know, historical period of time. So room temperature versus set point, CFM flows versus set point, fan statuses, all that information can be compared and analyzed to draw conclusions as to what the problem may or may not be. And most often, we can get very, very close to determining what you know, is happening on site. We may not be able to know what desk the electric heater is under, but usually we can figure out what's going on. You know, it's if the heat's turned off, and we can, for example, that VAV box that we looked at a moment ago, if the room temperature were satisfied, and we look at the historical data, the room temperature stays satisfied all the time, and the room is actually hotter than it's supposed to be, but yet the room temperature is still rising, and we have the discharge air temperature telling us that the electric heat is in fact not running, we can determine that there's heat being introduced by another source. So, as I said, we may not be able to figure out which desk it's under, but we'll know that there's an electric heater on site if it's an office environment. This site we just turned on a few days ago, so we don't have that much historical data, but in most of our projects, and this isn't specific to one manufacturer. Most all control manufacturers' equipment has these features in one you know, form or another. You can go back, you know, months and in fact years, you know, just trend data for long periods of time and analyze it. You could plot a whole year's worth of data on one graph just to see what it looked like, and or a week's worth to see that the building's going occupied and unoccupied as it should. And that trend data we find extremely valuable in one of the later aspects of the projects, and that's commissioning. So we'll go over that in a few minutes. But back to what we were headed to is the actual cycle of the project. So we've actually, you know, back to where we started from, we've actually designed the project and we've submitted on it. Most oftentimes what's going to happen is the mechanical engineer will, you know, approve or modify our submittals to make sure that the project, to add integrity, that the project is going to be installed the way it was, you know, specified. Then we'll actually dive into the installation. We do that with our own folks. Some control contractors will sub the installation out, because that's probably it can be considered one of the less complicated aspects of the project. It's pretty straightforward. If you're given a schematic and a set of mechanical drawings, you can pretty much install it. It's if on a basic job, it's not you know, too difficult to get that done with somebody with experience. We like the consistency of our projects to be, you know, the quality to be very high, so we prefer to do that in-house with our own folks. We don't subcontract any work out. And when we do that, we can actually ensure that we're meeting our UL requirements, making sure our panels are UL listed, and making sure that once our panel is UL listed and it goes out to the field, that an installer is not installing other devices in that panel, which would wreck the UL listing of the panel. So we want to maintain that integrity all the way through the whole process.
So it gives you the ability to make sure there's somebody there doing what needs to be done. It doesn't have to be the same person.
Exactly, yep, yep. And there's huge challenges with installation too. In contracting, you know, you're probably, you know, we get the general contractors that jump up and down and throw hissy fits if we don't have folks on site every day of the whole project is operating. Well, we're building automation contractors, so we come and go. You know, typically, our typical installation will have us on site as the building's being roughed for a new construction. The building's being roughed in, we'll have our guys in doing our rough, and then we're gone. We're out of there until the mechanical contractor has all the mechanical equipment installed. Once that happens, then we come back, we'll do some more work installing our devices and terminating our devices, and then we're gone again until they're ready to start doing some startup. That brings me to the next component. Once when we the one person that was, you know, more or less in charge of the installation on site, he'll spend a day on an average sized project with our programmer. Somebody that actually comes in, sets up the controllers and programs them. Now, and I can speak for, we service a bunch of different manufacturers' controls. Johnson, we do a little bit of Honeywell, Allerton, Automated Logic. There's a few other ones, but our primary focus is with KMC. All of KMC's controllers are fully programmable. So it means when you open a controller out of the box, it's empty. So whatever goes in there to make the stuff happen, it comes out of our minds following whatever written sequences we're supposed to adhere to. There's some differences with other manufacturers' product. For example, Johnson Controls has the unitary controllers that they're not really programmable, they're more or less configurable. A lot of the manufacturers offer product that is configurable for the marketplace, for the field, because it goes together a little bit faster and you can save some money and save some time in setup. So if you have a typical air handler, I mean, you know, our standard, you know, 5-ton rooftop, there's only so many things you can do with a 5-ton rooftop. So some manufacturers have offered controllers that have application-specific programs already built into it, and you just kind of go through either a question and answer process to set up the controller, or simply turn it on and maybe make some adjustments. The advantage to that is a control contractor can get in and get out with a lower qualified person, a lesser qualified person, perhaps, to set up that controller and maybe make some more money. So there's a need for that product on the marketplace. Our products that we typically use are fully programmable, so you know, even the most basic sequence we're gonna write. Fortunately, you know, it's software on computer, so we can just, you know, copy and paste, you know, so we don't have to reinvent the wheel for the most basic functions. But you know, we're going to check it out as though we wrote the program for the first time. That startup process can, on a project like the school I handed around, that startup process could last, depending on, you know, how the project comes together, from, you know, a week to 3 weeks typically on site, you know, for a fairly good sized job, where we're going through and starting up all of the controls and programming them.
Confess you get antsy after 2 weeks, so.
What's that?
I say confess that you get nervous after you get back after 2 weeks.
Oh, sure, yeah.
Crisis.
Yep, it can be. I mean, you know, obviously contracting is, you know, we're going to try to, you know, maximize our profits by being as efficient as we can and getting the job done. So so we want to do a good job. When the startup process happens out in the field, when it just initiates, that's typically when we are designing and implementing our front-end graphics package. That actually doesn't usually hit the site in force until the end of the job, primarily because there's things that change at the startup phase. We find out that the rooftops that were specified aren't the ones that showed up on the job, and now we're going to have to modify everything. So that's usually when all the bugs come up to the surface. Any mistakes that were made on the job by different trades, will come to the surface. So oftentimes we're called upon, as building automation contractors, we're called upon to get creative on projects to make it all come together. So while a piece of mechanical equipment does what it does, it runs, it stops, it heats and cools, the sequences that we employ will have a lot to do with how the building is going to operate. So, for example, let's just to try to give you the basic example. If a rooftop doesn't have the factory economizers that they were supposed to have, but yet we have to do an economizer control option, we can just simply add the programming necessary to do that in one of our controllers and still meet the sequence. And in contracting, we may just do that and get the job completed. If there's a extra cost in product or significant extra time involved, we would probably ask to get compensated for that. But the nice part about it is, and this happens on a lot of jobs, especially design, build, and renovations, we'll be called on to add more value to the project to make things happen. Once we get all the startup done, then we'll start checking out the sequences. So we'll actually simulate all the conditions that the building will be operated in, and basically run the whole system through its paces and make sure it operates how it's supposed to. So, for example, if a classroom has a carbon dioxide monitor, and we're going to monitor CO2 and do demand ventilation, we'll actually introduce carbon dioxide to the sensor, raise the carbon dioxide level in the room, and make sure that the mechanical equipment operates. Yeah, so we make sure we sense the CO2 and that the equipment that's supposed to add ventilation actually does what it's supposed to do. So we'll do all that on our own. Very important is this sequencing and this checkout process. Is some projects in different states are different. I don't know how Pennsylvania handled it, but New Hampshire is not real heavy into commissioning yet. They're just getting over the hump here. A lot of states, like for Vermont, for an example, any municipal job in Vermont is required to be commissioned by an independent commissioning agent. That means after we're all done and we've said that everything is operating the way it's supposed to, they'll bring an independent third party in to work with us and to validate our system and verify everything does in fact do what we say it does. And that's nice. We actually, believe it or not, as contractors, we prefer it that way because once our system has been validated and it works properly, if somebody accuses us of not having a properly performing system, we can just refer back to the commissioning report saying, well, on this date, it did perform the way it was supposed to. So now let's look at why it's not now. And we often will find out that somebody has gotten into the set points and made some poor choices in set points that have affected the operation of the system. We'll find situations like that. So as far as commissioning goes in New Hampshire, I'd say the past year we've seen an increase in the number of projects that are independently commissioned. I mean, really commissioned. We have a few engineers that will typically have the balancing contractor work with us in the project, just to get a set of eyes on the job to see if it works operates correctly.
Well, that's a good thing to do, though.
It is.
Because if somebody comes in and balances and then you come in and do your stuff, it never seems to work out quite as efficiently. It takes more, it seems to take more time. The jobs that I've done when we've had the balancers there, when we were bringing the system up, it was a lot easier to, because right then you can make adjustments, you can make changes if you need to.
Right.
Because it might not be in your software.
Oh, exactly. Yeah. It could be that somebody kinked the ductwork and
Exactly.
we need to get some more airflow into a room, so we'll do something different in our side. Well, an interesting thing is and our industry is always changing, and some folks will get different ideas and they'll try them out. Sometimes they work, sometimes they don't. Having the balancer commission our job is good because it gets another set of eyes on the job and on our project and our system to make sure it's working properly. So we welcome that, and we work with the balancers to make sure that the system, they're satisfied and they sign off on it that it was working correctly. and that's good. It's better, though, when a actual commissioning agent is actually, you know, adopted onto the project, because then, you know, this person, that's their primary focus, whereas a balancer does understand how a system works, and they may understand how the controls go together, but they may not really, you know, fully appreciate some of the sequences. Most jobs that are commissioned by a commissioning agent, he not only reviews the fact that our system is conforming to the sequences and to the specifications that were, you know, contracted, but he's also looking at the overall big picture of that project. So it never fails that a commissioning agent will actually say, well, I know the sequence says to do this demand ventilation, you know, sequence under these conditions, but how about if we tried this? Would this make more sense? They'll actually question those sequences a little bit and maybe even add some value. And most of the time it'll take a phone call to the mechanical engineer and just get a clearance to make some changes, and that's all done on the fly at literally no cost to the owner, where they're doing commissioning anyway. So if we actually refine some sequences and make it a little bit better, it benefits the building and the owner ultimately. So,
You mentioned you talked about commissioning earlier.
Wes?
Have you seen any numbers on cost benefits of commissioning? And I'm asking this with a different hat on, that I'm on the advisory board to the climate task force, and we're looking at ways we can cut carbon in the state, and one of the things that comes up is commissioning, and then there's always this, well, is that, you know, isn't that a burden to require that to the owner if it were to be, as a policy decision, to be required, like maybe like you were describing in Vermont?
Yes. You know, as a contractor, further down in the project, the end of the project, what we typically do is we offer the owner, the building owner, a relationship with us. We give the owner all the tools and training necessary to operate their system and to do what they need to do, but we want to have a service relationship with that end user, and what we typically do that is in the form of a service contract. Maintenance agreements, service contracts, technical support agreement. If you think about a mechanical system, let's just look at a rooftop. That rooftop will work great the first year in operation, but if you never change the air filters and maintain that equipment and change the belts, the operation and its efficiency will deteriorate quickly over time. The exact same is true for a building automation system. If you're not maintaining it, its integrity will deteriorate over time as well. In different ways, though, and sometimes not in as a noticeable way. But for example, if we're controlling outside air dampers, if the dampers start getting sloppy over time, and if the control system says, well, we're in the heating mode, let's close the outside air dampers because we don't need ventilation right now. If those dampers don't close fully and you're drawing in, you know, more outside air than what you need to on a cold New England day or night, your energy efficiency of that building is gone right out the window. And the danger at that, as a building owner, it's something that's gradual over time. If a room sensor degrades over time and drifts off of an actual temperature, so for example, if our building automation system right here, if we're saying that the room temperature is 70 degrees and we're controlling to maintain that 70 degrees, if that sensor is off by 3 or 4 degrees, you can imagine that we're going to potentially waste a lot of energy or make for an uncomfortable environment. So for commissioning, we kind of look at recommissioning our building automation systems as a ongoing process that we offer that service. Our service agreements, usually depending on the system, will have us come back to the facility no less than 2 times a year and go through the whole system in sequences again, and not only just refine or check all the sensors and dampers and all the control components and make sure that they're working and calibrated and tuned up efficiently and to operate efficiently and accurately. But we also look at the overall building itself and the facility itself. So one of the components that we do is talk to the building owner or manager, whoever's, you know, we're usually interfacing with, and whoever's at the building mostly, and ask them, you know, how do you like the way things are running? and we'll get ideas as to, you know, changes that have been implemented, and we'll come up with concepts and maybe ideas that of refined sequences that will serve the building better and save more energy. We took on a project as a service on a control system that wasn't installed by us. It was installed by another control contractor. We were asked to, years down the road, to come in and look at the facility because the owner wasn't satisfied with the level of service that they were getting and the performance of their building. So we came in and, you know, found that the building was operating okay. I mean, the heating and cooling was coming on when it was commanded to. The boilers were cycling and sequencing properly. On the surface, first blush, everything looked like it was okay. But the building, you know, occupants weren't satisfied that things were the way they needed to be. So we dug deep and went through everything, and we just made, you know, just basic common sense changes. One of the big things that we did is they actually had 2 rooftops on the roof, and that fed into one common duct system. And we looked at it and said, geez, the original, we got our hands on the original sequence of operation as well. So we made sure that we were fairly close to the original sequence when we started, and we were. The system was performing more or less the way the engineer had actually intended to. But we looked at this rooftop situation with 2 big rooftops feeding into one common duct system. And there was isolation dampers at the supply and return air of both rooftops. And I looked at that, we just kind of questioned, you know, why those were there. And the dampers were just sequenced and programmed to be open all the time. Whenever the building came occupied, both rooftops started up and ran. And then as the VAV boxes, you know, modulated open or closed, the VFDs and the rooftops would modulate up and down. And so it seemed on the surface fairly efficient. Working with the building operator, he questioned why that was the way it was, and we couldn't really come up with a good answer. And he, you know, we you know, asked and answered some questions as to why both rooftops start at the same time. And we thought about it and we said, well, geez, those are good-sized rooftops, and under, you know, average spring and fall conditions, I bet you we could operate the whole building with just one rooftop, and especially if we're doing economizer cooling and so forth. So everything mechanically was there, and control-wise was there to change the sequences. All we basically did was go in and fat finger in a different program to basically operate the building whenever possible with just one rooftop. And we added further programming that if one rooftop wasn't keeping up, then we bring on the second one and ramp them both up. And the bottom line was this, and we didn't learn this for a while afterwards, but it took a little bit of time for us to get all the information from the municipal entity that we were working for. But after a whole year of the system, you know, being changed, they came back to us with some information that I really like. Their gas bill, they used natural gas to heat the building in January, and a very cold January, I might add, was less than their gas bill in July. Wow. Before we took the building over. So they were actually providing or maintaining more heat or adding more heat into the building in July than they did in January. Since then, you know, I don't have exact numbers, but they're you know, pretty confident that we're saving them in excess of $2,000 a month, every month, just in those sequence changes. So we didn't, and we didn't do anything, you know, to cost them a whole lot of money. I mean, just a few hours of programming and spending some time. So that's, you know, in talking to Wes, you know, that recommissioning process in the building automation industry is invaluable. And we don't really call it that, but we call it a service contract or maintenance agreement. So we'll actually go into a facility and, you know, hopefully it's one of ours that we've installed, you know, and work with the building owner and you know, take a system and try to, you know, use it to its fullest potential that we can. And that kind of wraps up, you know, after the warranty process is all done and we've shaken out any bugs that may exist in the system. And you know, we are contractors and we're humans, so these sometimes systems don't come together as, you know, perfect as they should. There's always
A learning curve.
yeah, well, there's learning curves from the building owners. There's also you know, some conditions that can develop in the building that may be undesirable. So you know, while an engineer on paper has designed a mechanical system to to maintain a facility. When that system is actually brought online, you know, we see all kinds of nuances that can happen. For example, we have a gymnasium at the New Hampshire Tech down in Nashua we're doing right now. We're struggling with a little bit. The mechanical system, it's just not getting the heat down to the floor. So it's, you know, hot up high and it's cold down at the floor. And you know, they're trying to, without redesigning the mechanical system or the ductwork to distribute the air differently, they're looking to our control system and our sequences to try to, you know, manipulate the system in such a way that we might be able to mitigate the undesirable, you know, functions that they're observing now. So back to, you know, the controls and how we can, you know, use them to everybody's advantage, that's a huge way right there. I mean, because, you know, the sequences are adjustable. I mean, I wanted to show you a program. This might, let's see, right here. What I did is I just took I grabbed off my one of my backups. Our controllers, we can actually export our control program from a controller into an HTML or an Excel spreadsheet. And it's kind of nice to be able to just put this is everything that exists inside in one DDC controller. This is just one controller that operates one group of one penthouse, one piece of equipment at a office building out in New York that we service. This right here, this first group is outputs. These are physical outputs that are wired to the controller. So we have a VFD, an exhaust damper command, oops, that's a spam thing here. These are analog outputs. They'll start off being analog, 0 to 10 volt output, and this is just software label here. So when our programmer gets on site and takes a controller from scratch, when we turn on a site, this is all blank. There's nothing here. We actually type all the stuff in, or copy and paste, whatever the case may be.
So you could actually copy and paste this guy because it'll save you time, right? If you do a gymnasium, I'm just thinking like general aviation. I know of general aviation like hangar.
Yep.
And it's set up almost exactly the same.
Exactly.
So you could.
Oh, sure. I mean, for example, if the FAA built another tower identical to the
Use the same.
exactly.
Or likewise.
Yep. And one thing that we have done is the FAA, they do kind of like boilerplate specs. They write their own specification. They have their own engineers. I forget the guy's name that we worked with. Bill Crenshaw is the engineer system for the tower in Manchester. When we met all the sequences, we actually, when we get done, not everything's perfect. Some things didn't work the way he intended them to. So we sat down with him, with Bill Gates, and with a few other folks at the airport, and we came up with some different sequences, some changes that would make the most sense. He wrote all those down. He actually, rephrase, he made me write them down. Then he took them, and he put them in his spec. So theoretically, and this could happen, it may happen, we've offered our services to other dealers. If another KMC vendor gets a tower or is awarded the contract for a tower just like the one in Manchester, say in Atlanta, Georgia, we could give them our programs and they could just use them and our sequences and everything would be done. And we do actually work with other dealers to make information like that available to other dealers. Oh yeah, absolutely. Well, believe it or not, yeah,
But presumably you get that in return when you get the right job.
exactly.
You get the right job,
Yep.
you get a happy customer. you
I was
know,
gonna say,
for
it
somebody
goes
else.
back to customer service and
Customer
camaraderie with people in the field that are working for the same end.
Exactly. I mean, there's competition. There's a healthy competition, and in our industry, here in New Hampshire, right here, there's a lot of competition for controls for building automation. We have Johnson Controls is really strong in this area. Honeywell is here. Siemens Building Technologies is here.
Control company over in Manchester too.
Yep. Control Technologies.
Yeah.
Yep.
I ran one of their guys up at Ground State.
Yep, they're a big outfit. I actually used to work for them myself. Good company. There's us. There's a whole host of smaller ones. IB controls. I can't even think of the names. There's quite a few. But we may not talk a lot to each other here in New Hampshire, but there's kind of another little niche that happens with controls manufacturers. The manufacturer that builds a control product will actually make a network that all his dealers can work within. So KMC Controls has a network of support for them, and they put all of us dealers that sell KMC controls throughout the world in contact with each other, and we meet each other at at different conferences and so forth, and that's very, very powerful. Not only is it good for us to have that team effort and support, but it's also kind of nice and unique to see what other areas, other territories are doing for sequences and different innovative ideas. Like, believe it or not, California is kind of unique. They try all kinds of different things, and we have a dealer out in California that we'll talk to them, and they'll ask us if we're doing this particular sequence. In fact, they were talking about demand ventilation before we ever saw it specified here in New Hampshire, and now that's almost commonplace here in New Hampshire. So it's kind of unique to get that information. Allerton Controls has a good dealer network. Invensys, Johnson, they all have their own network. So they work, you'll work with your other dealers. And it's kind of like, Bank Chevrolet here down in Concord. They're Chevrolet General Motors dealer. They work with other dealers, in conjunction to share cars, to help each other out with sales efforts and so forth. Much the same. We've protected territories with product. For KMC, there's no other KMC dealer, in New Hampshire that can sell a product unless of course, we authorize it. But we would be the focus on KMC controls, just like Johnson, does all the high-end Johnson controls.
Did Johnson take over Efficiency or merge with them or something?
No.
Talked a little while back, I was actually working for that.
No. Not Invensys, no. There's been a lot of consolidation in the building automation industry. Let's see, I'll start off with Allerton. Allerton started out in Seattle, Washington as a $12 million a year control system manufacturer. They got bought out by Novar Controls.
In supermarkets.
Yeah, exactly, yep. Yeah, and they do a lot of BJs and all those type of, canned type applications. Novar's a European company. They're very, very big. Novar, then they got bought out by Honeywell. Honeywell actually owns Novar and Allerton now. Johnson recently purchased or merged with or acquired York International. So York is the one that they grabbed.
Okay.
So
I know they were talking, I think it was 3 years ago, they were talking about trying to, them and Invensys were sort of.
There was a lot of rumors a few years ago. Invensys was on the chopping block. That thermostat, interestingly enough, is a Barbara Coleman thermostat. That's probably a TC1101, if memory serves me correctly. It's just a mechanical thermostat. Barbara Coleman is one of the first control manufacturers. They got bought out by or merged with or changed their name to CB Environmental Controls. Then they changed their name to Invensys Environmental Controls. And then now Invensys got bought out by Schneider Electric, which is TAC, Tor Andover Controls, which owns Andover Controls, Square D, I believe, a whole bunch of giant, these are giant, big corporate conglomerates that I wouldn't even, but it's big. KMC Controls, not that I'm trying to sell their product, but they're the only independently owned control system manufacturer in North America. That not bought United States. There's one other one in North America, up in Canada, but they're wholly owned by the Kruder family still. It's been passed down for 35 years through several generations.
This is kind of a question in a different direction here, but this class is one of the projects we're working on is an energy audit of the CAT building next door.
Yep.
And what we think we've found is that there's a control system there that completely doesn't work, that most of the other envelope and HVAC lighting systems are fairly up to date.
Mm-hmm.
And we're trying to figure out what it would take to get that control system working, and what it would cost and what the benefits would be. Is that something you would be able to help us
Oh, absolutely.
determine?
Very easily, yep,
Yeah.
absolutely. As memory serves me, that project, we bid on that back when I was probably the building about 3 years old. We did bid on it. We were not the successful bidder on that job. Our competition was awarded the project and did the installation. I actually sold the VFDs over there, though, so those are our VFDs. I really haven't been in the building. I think we were called in there once to look at something, and I don't think that went very far. That control system is, I believe, an Allerton control system with a Tritium front end computer. Tritium is another manufacturer. I think they're actually owned by, well, they kind of moved around quite a bit. They're mostly owned by Honeywell, I believe, now. Honeywell actually now owns Allerton, too, so it's kind of, you know, the way things all kind of circle around is unique in our business. But that system is, I believe all the software is on site to be able to service that. So it is pretty straightforward to you know, get into the sequences and see what's going on.
If you could define how we might approach that and continue from here, given that there's essentially a month left in the class. Maybe
Okay.
it's undoable in that time.
Well, I mean, you know, certainly the hope would be that, you know, there's a front end, you know, similar to, it doesn't have this software package, but in hopes that there's a front end that's functioning that's similar to this that has data, trend log data available in it. So, you know, the first thing I would want to do is to talk to the people that are actually in charge of the building and that are in the building mostly, the maintenance staff here, and ask them, first question is what's not right about that building? Because those folks most of the information. Well, I can't control this. You know, they may not be able to control certain components the way they think they should. You know, that's just information you want to gather. They may say that these areas are hot, these areas are cold. That's all information that you want to get. Then the next thing you want to do is look at the trends to see if the building is, you know, operating the way it should be.
It would be beneficial for us to get like a year worth of trends or at least a couple of months.
If that's, whatever's available for information, you want to gather all the information you can, you know, to make an evaluation as to, you know, how it's operating. Then the next thing, you know, the next step is to probably just exercise the system through its sequences to see, you know, just a brief, you know, I don't want to say commissioning, but a brief sequence check to see if everything is operating the way it's supposed to. You know, are the economizers, you know, functioning correctly? Is the mechanical equipment operating? You know, you may find that some things that I think there's an energy recovery unit on the roof, I believe, or one or two of them. You know, are they working properly, and are the wheels clean? You know, is everything, you know, happening the way it's supposed to? So those are the things that, you know, you'd want to just, you know, kind of grab the most information, most vague, you know, basic information to assemble that to see what, you know, how far you need to dig into what areas. You may find that you have 3 or 4 controllers that are offline and that some equipment just may not be working. Could be something as simple as that. And it's just, you know, in a standalone mode running in full heat or something. So there was one other question, I think, Wes, you asked about, you know, what do we do if, you know, if the system fails? Well, if the electricity goes out in the building, you know, everything's off, so we don't really care. But part of your question was what happens if the building automation system fails? And I hadn't answered that yet. The building automation systems, when we design them for worst case conditions in New England. So we take certain considerations in mind or take certain considerations in mind as to what they want to happen if the system fails. So for example, if we have a boiler plant, we'll have handoff auto switches on all of the heating equipment in a boiler room. So if the control system fails, the maintenance person need only walk into the boiler room and flip it into manual and then allow the boilers to operate on their own operating aquastats and allow the pumps just to run, you know, in a standalone mode. So now you're generating hot water and you're throwing it out into the building. Then what's going to happen? Well, when we design our control system, we design it in a fail-safe mode, typically in full heat. we're in New England, so we want, if we're going to fail, we want things to fail into heat. While that's unfortunate in the summertime if it fails, you know, the worst situation is you're going to have, you know, a wasted energy in a hot building for a short period of time until it's discovered and fixed.
Do you run into the program for it to be seasonally controlled? You know, like if you're in the summer season and you get failure to just shut down?
Well, in some cases, the answer to that could definitely be positively yes, but we try to even take our design a little bit further. What happens if somebody turns the breaker off that feeds all of our controllers and our relays and everything? We'll have normally open spring return valves on the baseboard, so now you've got, you know, everything is off. For example, let's say, you know, the building automation system pooped out in the middle of the night or over a long weekend. So we want, when the folks show up to the school on Monday morning at you know, 7:35, getting ready to open the building up for the kids to show up at 8 o'clock, we want the worst situation for them to discover is the building's hot. We don't want them to discover the building's frozen up and the pipes are all burst and they've got other, you know, catastrophic problems in the facility. So we'll typically fail to full heat mode. We actually service some of our customers here in New Hampshire that we've built relationships with over the years, have facilities in other states that we actually are carried, we're brought, you know, in other areas of the country to service buildings. And with the networking and computers the way they are, a lot of the work we do right from here. But we service a lot of equipment down in Florida. And believe it or not, it's just it's difficult for us to adopt their mindsets down in Florida, because up here we're, yeah, and they're fail-safe, you have full cooling, and, you know, they don't want to be hot. In fact, the last time I was down there, I was in a gentleman's office, and I was doing some training, actually, and I was in his office all day, and it was freezing cold, you know, and this was in the summer even down in Florida, but I don't think it could have been much more than maybe 66 degrees in his office, and I mean, I was shivering, because, you know, I was trying to dress for Florida, and I froze all day. I asked him, I said, why is it so cold in here? He says, well, you got to keep it really cold in all the spaces. And they're serious about this. They keep it really cold to get their core temperature down so that when they go outside, they can, you know, deal with it outside. It's so oppressively hot and humid out there. That's his theory in their facility. But it surprised the heck out of me.
Nobody's falling asleep there,
Oh, no, no.
Well, they're not worried about saving energy, that's for sure.
No, not,
Suck that sucker up.
yep, yep.
Bring in your cold meats.
We got our own hydro generator.
Well, as a matter of fact, I had this laptop with, you know, when I was down there, and this is a fairly decent laptop, and it was so cold in the office, my monitor was a lot dimmer than I'm normally used to. And I was having a hard time even working on my computer. But
What, the frost off it?
yeah, just about. Yeah, we scraped it every once in a while. So, yeah, but it's just a whole different mindset. Their sequences are all different. I mean, their humidity is their big thing, and they do a lot of heat. They, you know, a lot of reheating, I should say, and a lot of that what they do is with electric heat. It's just a, you know, mind-boggling, you know, concept down there. It's totally different. So we struggle a little bit with it with a few customers that, you know, that bring us down there for their facilities. But when once we get our head into the swing of it, it's, you know, it's working with the documentation. So in the commissioning, I've kind of made some notes as to what a few of the folks that we're working in commissioning the buildings, what they're looking for. And most of the time, it's like a 10-point approach to commissioning. They start off with a plan. And I really like this. The commissioning agents that we've worked with, without exception, every one of them I've worked with so far have been, you know, good folks to deal with. Their commissioning plan has everything laid out in it, typically, as to what you expect as a control contractor, what we expect we're going to have to do, and how our system is going to have to perform, and what they're going to be looking for. So it makes it easy for us when we get that plan before we even install the project, to have our T's crossed and I's dotted before they show up, and, you know, hopefully make our system and our project look good. In addition to the plan, they'll have a schedule. The commissioning actually happens in a lot of phases, you know, with a new building. And this is just commissioning the building automation system. This isn't commissioning the whole building, Wes. So if you know, your stuff may be, information may be different, but the schedule will show the commissioning agent coming in during the installation process and having certain meetings, strategic meetings, to review spot areas of the installation to make sure the installation conforms to the whole contract. Then they will have the basis, he'll have an identification of the basis of verification, you know, what points are going to be verified and why, how. He'll identify his whole procedure of commissioning. Then they'll have a whole, you know, part of the commissioning process is just reviewing our shop drawings, what I call the submittal process. They'll actually go right through that and make sure that that conforms to the whole project. Some engineers have very, very unique requirements on our